Today we're going to look at quadratic equations and more word problem situations. So the first example, if you throw a ball or shoot an arrow, fire a missile, throw a stone, it will go up in the air, slowing down as it goes, and then it come down again. It will speed up when it comes down. And a quadratic equation tells you where it will be when it lands, or at any point. A ball is thrown straight up from 3 meters above the ground with a velocity of 14 meters per second. When will it hit the ground? So if we draw a picture of what this will look like, here would be like our x-axis and our y-axis. And let's say we started 3 meters above the ground. Our ball is going to go up and then down. And we're going to look for where it hits the ground. So this is our x-intercept. This is our y-intercept. Here's our maximum. Here's our line of symmetry right here. I didn't draw my line very well. Line of symmetry is if you were to fold it down the middle, and technically it doesn't have a min or max because it keeps going down, or it doesn't have a minimum, it has a maximum. Ignoring air resistance, we can look at these factors. The start height, it travels upward at 14 meters per second, and then gravity pulls it down. And we're going to look at this equation. So right here's the equation. Notice it's a quadratic. T squared is the highest power. It says, what height will the ball be at when it hits the ground? Well, if we look at the graph, it's going to be at a height of 0. So the height's 0 when it hits the ground. Explain how we can use the equation to figure out when the ball hits the ground. Well, we can use quadratic formula. And so let's do that. It says, use your equation and quadratic formula to solve the problem. Be careful when finding A, B, and C. Show your work below. All right, so first step is to identify A, B, and C. Let's take a look at our equation then. So A is the number next to the x squared, and here it's -5 next to the t squared. B is the number next to the x, in this case t, so that's 14. And C is the number by itself, so in this case C is the 3. I'm going to plug in a quadratic equation. X equals opposite B plus or minus the square root of b squared minus 4ac all over 2a. So we're going to figure out these three numbers right here. So we have x equals -14 plus or minus the square root. We'll type this in. So let's go back to Scratchpad. Let's clear this. All right, we got, excuse me, 14 squared minus 4 times -5 times 3. So that discriminant is 256, which means we're going to have two solutions because it's positive, all over -10. Now we split it up and do the plus and minus. Let's do the plus first. So -14 plus the square root of 256. Hit enter. Divide by -10. So one answer is -1/5. Oops, -1 divided by 5, which is -0.2.
Good morning. Juniors who were invited to the Genesis Works
Let's do the minus.
interview prep session. The interview prep session is going on at B225 right now. Juniors invited to interview for
All right,
Genesis
so the other
Works.
answer is 3.
There is a prep session going on at B225
So what that means
right
is
now.
we're going to look at the positive one. When does it hit the ground? Here's the negative one. The positive one, so we say the y value equals 3 right here. So the 3, actually the y value is 0. The x value, the x-intercept is 3. So it takes 3 seconds to hit the ground. So here's the answer that we're looking for. It says plug your equation into this and use your calculator to find out when the ball hits the ground. So this is how we can check our answer. So again, I'll go to Scratchpad and let's type in that equation. 3 plus 14. We have to change our t's to x's. It was minus 5x squared. Okay. We should get 3 seconds, and you can see right here that we do 1, 2, 3 seconds. You could do menu, analyze graph, and find the zeros as well. And so you can see that, yep, it took 3 seconds for the ball to come back and hit the ground. Okay, last example. The height and feet of a bottle rocket is given by this equation, where t is the time in seconds. How long will it take for the rocket to return to the ground? So if we draw, let's say it took off from the ground, it's going to go up, hit the ground again. So this is what we're looking for, right here. First step, let's find A, B, and C. I'm going to erase this actually, give myself more room. So A is the number next to the t squared, which is negative 16. B is the number by itself, B is the number next to the x, which is here at t, 160. C is the number by itself. There's no number by itself, so 0. Let's plug in a quadratic equation. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. Let's figure out these 3 parts of the equation. So x equals negative 160 plus or minus. Let's calculate 160 squared. And if you look, minus 4 times negative 16 times 0, that turns this whole thing into 0. So, I mean, I'll show you here. Negative 4 times, what is it, negative 16 times 0. So we should get 160 squared. And then we'll take the square root of that, so 25600 all over negative 32. We're going to split it up. We get negative 160 plus the square root of that 25600. So 0, and 0 divided by anything is 0. So the one answer is 0. And you could see why if I had kept my picture up there. It's taking off from the ground and going up and down. So here's the 0. So now we need the other one. So it's going to be negative 160 minus the square root of 25600 divided by negative 16, negative 32, I mean. All right, so it's going to take 10 seconds. For the ball to hit the ground. So your assignment is to read through the problem, try quadratic formula, and be able to solve word problems using quadratic formula.